All right, this is 4.3, number 19. I want to at least get you started with this one. So we're finding critical numbers, intervals of increasing, and intervals of decreasing. And those intervals change, increasing and decreasing, where you have a critical number or it can be where you have an asymptote. Okay. So let's find our critical number through finding the derivative. So g prime of x, it's negative e to the negative x plus 3e to the x. And I have a negative exponent, so there's meant to be a denominator here. So I'm going to factor out an e because they both have an e. And I'm going to take the lowest power that I have, which is negative x. And so what I do is I rewrite the original equation. And to find out what I get from factoring, I divide by the same thing that I'm factoring out. So you're multiplying by e to the negative x on the outside, and you're dividing by that on the inside, both terms. And this is still g prime of x. We're just making it look a little different. So we have g prime of x is equal to e to the negative x times these cancel. Love when that happens. And then we have plus 3. And here, you know that when the bases are the same and you are dividing, you subtract the exponents. So this would be upper exponent x minus lower exponent negative x. X minus negative x. So this is going to give you e to the 2x, x plus x. So now we can, I don't know, let's move that e to the negative x down for sure. That has to be done. Probably in your book they would put the 1 behind the 3e to the 2x. So it would look like that. And to find critical numbers, we're going to set the numerator equal to 0. To find where the first derivative is 0, that makes a critical number as long as that point is in the original domain. And set the denominator equal to 0 to find out where the first derivative is undefined or doesn't exist, because those also make critical numbers as long as that value is in the domain. So for e to the x equals 0, there's no solution. E to the x is never 0. Even when you put it 0 where x is, e to the 0 is 1. So there's no solution, meaning we're not going to get a critical number from that. Let's do the other one maybe below. So I think it's going to take some more room. We have 3e to the 2x minus 1 equals 0. Moving up. And I'll move the 1 over and divide by 3. E to the 2x equals 1/3. And now I need to apply the natural log to both sides to free my x. Natural log e to the 2x equals natural log of 1/3. That'll give me 2x equals, and natural log of 1/3, if you happen to look at Calc Chat, they're getting a little tricky here. So we'll do what they did so you understand. This can be written as 3 to the negative 1 instead of 1/3. And then what we're going to do is we're going to move the negative in front. Exponents can come forward as factors when you have logarithms. We know that from doing logarithmic differentiation. So 2x equals negative natural log of 3, which all of that is just some number you'd get from plugging it into your calculator. And then we divide both sides by 2. So here, this weird number, whatever it is our critical number. So you are going to first make sure it's part of the original equation. It really is part of the domain, and it is. And so you would plug that into your calculator, which I don't have with me right now, so I can't. And then you would know where it is on the number line. So you would really want a decimal form to find out how to choose values that are on the right side of it and on the left side of it. And so once you do that, you'll test an endpoint here to find out in the first derivative to find out if you're increasing. Test an endpoint over here in the first derivative to find out if you're decreasing. Remember, if the first derivative is positive, you're increasing. If the first derivative is negative, you're decreasing on that interval. Okay, sorry to not be able to finish this one, but I think I got you as far as you need here.